Okay, so this is Roberto Manduchi from UC Santa Cruz. I'm the panelist of this fantastic computer vision and AI panel. I have my dream team in front of me, and I'm very excited about that. So we are talking about computer vision. I like to call that the art of teaching computers how to interpret images and videos. And of course, we have it pervasive nowadays. We can get images with a smartphone, maybe with a camera. We have cameras on cars. We have images on the internet, on social media, news everywhere. Now, in terms of applications of computer vision in access technology, I think that we have all become familiar with things like OCR, thanks to applications like KNFB or SceneAI. So my question to you guys is, what is forthcoming? What do we expect to see pretty soon? And I'm talking about both the low-hanging apple and the moonshot in terms of applications of computer vision in accessibility. And I want to start with Patrick.
Yeah, thank you, Roberto. I think there's lots of promise here. In addition to traditional use cases like OCR, I think there's use cases involving kind of not only understanding digital content, but also understanding elements of the physical world. So not only text that you might see on a piece of paper, but also text in the real world around you, which is pretty much everywhere. Some other use cases that are on our team that are really of interest also are around understanding people. So understanding emotions that people may exhibit, facial expressions, descriptions of people, and things like that. And some other interesting use cases are around navigation. So helping someone get from point A to point B, or for instance, finding like a gate in an airport that they want to go to. So a lot of these have active research around them, but they're pretty interesting use cases that data is currently being collected for. People are researching the right way to create models that can help detect some of the elements in these use cases, and what the right UX and user flows might look like for these.
Very nice, exciting. So Cecily, what about from your team? What do you guys see coming?
Yeah, I think, as Patrick said, this view that we're going to start to be able to understand the world. In fact, we can, with a lot of the computer vision we do now, start to really understand the world. And then the question is, how can we make that into a coherent user experience? And the two things that we've been really focused on in our team is thinking about moving from a world where we have an image and then we have an interpretation of that image to an experience that as a blind person or a person with low vision, as you move through the world, the right information that you need is given to you that's interpreted. Now, that's, of course, very tricky because each person is very individual. So what you might like and what someone else might like might be very different. You don't want too much information. You just need the right information at the right time. But I think the real key is to move to a place where that information can be readily available in space, in time, personalized to you. And I think we're not very close, but we're not very far either.
Nice. The right information at the right time. I like that. Danna, you've been also working on exciting applications. What do you think?
So we have been working on, I would say, 3 key applications. One is building off of Cecily's statement about image descriptions, is describing images, but thinking about how to describe them appropriately for different situations. For example, on a shopping website, someone might want to know for a shirt if it has a pocket and what kind of embroidery there is and what kind of colors are going on. And that information is not obvious to someone who's blind, who's navigating the web. And another use case example of descriptions, people can want to know it for social media. So being more engaged in this kind of framework that in modern days we use for engaging with each other and building relationships. A second use case is still related to, for example, social media, and that is actually helping people to take high quality images. Someone who is blind is going to have a hard time to come up with the right focus, the right lighting, the right perspective. And so designing algorithms that can tell someone how to navigate their camera so that image can be higher quality, if you will. And that does matter to people who are trying to post their images to social media. And a third use case is called visual question answering. So not only describing an image, but actually answering a question about an image. So for example, does my shirt match my pants in the morning? Would be a natural question you might ask. Or when taking food out from the refrigerator, what flavor of yogurt is this, to know what you're going to eat? So those are 3 use cases that I think are coming in the pipeline and hopefully coming to real users sooner rather than later.
Beautiful, beautiful, fantastic applications. What do you guys have a thought about, how can we ensure that whatever we're going to build, whatever type of application, be it on a smartphone, be it on another device, can be used for everybody? Everybody will be able to access that. You don't have to pay a lot of money to get it. You don't need to spend a lot of money to purchase something. You have access to what you need. You don't need constant high bandwidth internet. Any thought about that? Who wants to pick it up? Cecily.
I think this is a really interesting challenge. And I know as someone coming from Microsoft, one of the challenges that we've taken on in the mainstream is making sure that whatever we build works across multiple devices. And it's certainly been something that we've been thinking about. How do you make an experience work on a phone that might also work on a wearable? It's not an easy problem to solve, but it's a very important problem to solve, and certainly one that we're thinking about.
Right, indeed. And of course, the fact that many things are now in a smartphone app makes it more accessible for everybody, and would say more equitable, provided everybody has a phone that they want. And I would say that probably the vast majority of people who are blind nowadays are using iPhones. What about, any thought about other segments in the world where not everybody owns an iPhone 12?
Yeah, just a thought on there, like I guess when we think of building for everyone, it's important not to just think of the Western countries, but also elsewhere in the world. And we do see a lot of usage on iPhone in the Western countries, but we also see a lot more diverse platforms globally, especially in developing nations like Indonesia, places in Africa, India. And these devices may be a lot different than what we're used to with iPhones. They might have less computing power, and the data usage among people in these countries is also different. They might not have access to Wi-Fi or reliable data connections. And so their usage patterns might be different. So developing for these users might require a more specific development effort than with Western users in Western countries.
And
I would just, sorry, go ahead, Danna.
This is Danna from UT Austin, and building off of Patrick's statement about looking at other parts of the world beyond just the Western world, even the kinds of visual content people are looking at is different. So the types of food you might eat in Indonesia is not necessarily the food you're going to eat in the United States. And OCR needs to work for all these different languages if you have text on the kind of food you have or anything you're buying. Toilets might look different, for example, in Japan from the United States. And so not just the hardware and thinking about how you design efficient algorithms that can run without access to Wi-Fi, but also understanding what visual content is actually available in those cultures really matters.
I think building on what Danna said, some of the work that we've just been kicking off is really thinking about how we can learn these different kinds of data. So at the moment, a lot of our computer vision are built off of standardized data sets that have been built in high income countries. And those data sets, ImageNet is probably one of the best known, look very, very different than the data sets that you might see as sort of the Dollar Street data set, which looks at data from other countries. But there are lots of new techniques coming out, things that are sometimes referred to as low shot learning or meta learning, where users would be able to train their own systems on their own things. And that would mean that regardless of whether that system was working in Indonesia or South Africa or Brazil or in the United Kingdom, that would work for that user. And I think that's one way where we can start to think about diversity in the cultures and the things that we look at, but also diversity in perhaps vision level. So what a person who's totally blind might find useful in terms of what they recognize might be very different than someone who has a much higher level of vision and is using that vision to do certain aspects of their daily life.
So very nice. So this is a good segue into what I want to talk next. You mentioned individualization. You mentioned, being able to adapt to each person's abilities. So where I want to move now is what I call the how. So computer vision, AI are exploding. Everybody wants to do that. All kids want to do AI nowadays. I see that with my students. Tons of conferences, tons of papers, algorithms tested, and everything. Well, the question is, that's all good, but how do I move that from that to building an app or system, an application that will actually work, but not only will work, that will be useful. As an engineer, I know that we are technology driven, and the thing that I see constantly is that we tend to propose solutions in search of a problem. We start from the technology and then we say, well, I'm sure you can use that to solve all of your problems. Well, that is not exactly how it works. And in fact, it takes a lot of time and humility to go and talk with the community, trying to understand how people live, trying to understand the diversity in the community. All right, so I wanted to ask you, maybe started with Danna. So what advice do you have for somebody, a person who is very well versed in computer vision and AI, who intends to build something that is really useful for somebody who has low vision or is blind? What is the right way to do that?
So I have two tiers of answers. And so all of it centers on understanding the target population. And I want to start off with an anecdote of how I came in with a solution to solve a problem. And so how I was guilty to answer the first component. So we built, as our team, a system that helps people shop online and learn more about the clothes on shopping websites. And we built this system, and then we went out and we did user studies with people who are blind and born blind, went blind later in life, and also people with low vision. And at first, the system worked really well with people who lost vision later in life, because the system spoke as you and I might listen if we're sighted, at a very, this pace of speaking. But then I went and provided the system with a user who was very proficient with using technology and screen readers, and the pace at which he wanted to hear was incredibly fast, so fast that I can't, as a human, understand it. And that was a real wake-up call to me not understanding the population and the diversity of needs. And so the first statement I would say to AI researchers is, if you can, go take part in a user study with the population. Talk to these people. Not even just a user study. Make friends with them. Get to know them and their real problems in their daily lives. So that's one aspect. But if you can't do that, there are communities such as this event that are creating communities where you have a chance to interact and learn more and be told what are the pressing problems. And so my team has actually created an annual workshop as part of the premier computer vision conference called CVPR, where we bring together people from industry and academia to come together and talk about what are the pressing problems and make progress on them. And so I would say, if you are an AI researcher, also look for workshops like those so you can go and learn from others who are doing these user studies. What are the pressing problems?
Very nice, thanks. Patrick, do you have any advice?
Yeah, I think that's great advice that was mentioned. Yeah, I think it's really easy to make some progress on the engineering side and then try to kind of fit that into a use case. I think one thing that we've tried to do is just develop a really good understanding of these, what we call activities of daily life. So common tasks that a user might need to complete throughout their day, and then do just a lot of user research and surveys to assess, like, where is technology meeting the needs of these activities and where is it falling? And so what are the opportunities for technology? And then in addition to user studies, like one thing we've been trying to do, which is fairly difficult actually, is have what we call a co-design process where we not only engage people who are blind and low vision through user studies, but we bring them in as more or less equal partners during design. So they help us conceptualize these opportunities and the goals of the product and the interface, and really are seen as kind of like a participant in the product development process. So that's something that we found to be really valuable, although it's extremely challenging, especially with the COVID situation going on now and having a hard time accessing people and having to set things up remotely and like that. So it's provided some difficulty, but I do think it's just like crucially important to involve these folks in the development process.
Beautiful. And COVID certainly does not help with anything that requires interpersonal relationship, user studies, focus groups, and the like. I mean, Cecily, any comments?
Sure. I mean, I think some of our work, because I sit in Microsoft Research, we're looking a little bit further out, and we're doing something similar to Patrick, but even going one step further, which is that it's our belief that the things that are 5 years out, it's really hard for a researcher to imagine them. It's very hard for a participant to imagine, right? Many of the people that we work with, they've built their lives up, they're successful in doing what they're doing, and all of a sudden you drop this technology, you say, well, how would you use it? It's like, well, I've got my strategies, I've got my way of being. But we've also found that these early adopters are also people who can push the vision the furthest once they have the technology in their hands. So an approach that we've taken is to build out prototypes, put them out there and see what people do with them, rather than trying to guess up in front. And a lot of what we've seen, and I can give an example from Project Tokyo that we've been working on. This is a technology, a visual agent technology that provides spatial sound about where people are in your 3D environment. And we expected it would be a way to support people initiating conversations, working in social agency. We happened to give it to a young blind person. I once called him a child, but he's 12, so I guess he's not quite a child anymore. And we started to find him doing unexpected things. And we started to find that he was using it to help focus his communication skills. He was using it to help guide who he didn't want to talk to. He was using it to help monitor how he didn't get in trouble in school. So all these things that would never have come up in a user study, we can start to explore. So I think these side-by-side partnerships that really help us explore the future by not imagining the future, but actually working out and being the future through trying things out and imagining where it can go.
This is intriguing. It's very interesting. You discover things after the fact that you would not discover even with your initial focus group. That makes total sense. Now, I have a question for you guys that's still related. So it is not just a computer vision algorithm, right, that makes the system work usable or not. The whole user interaction thing, how do I communicate? Do I speak to the system? How easy it is, and etc. So again, it sounds like it is not just the algorithm itself. Do you guys have experienced that in your own work? Cecily, you're nodding. So.
Absolutely. In some ways, I think sometimes the actual algorithm is the easiest part, at least within our colleagues. They're like, oh, I need to deliver you, person tracking. Great, done, delivered. But actually, most of what we've built in our system are what we call helper algorithms. So if we want to identify a person, if you walk into a space, well, the easiest way to identify them is you're looking at your face, but if you can't see who's around you, you probably won't be looking at their face. Or if you're a child and everyone around you is an adult, you won't be looking at their face. So a lot of what we've built are algorithms that help guide the user towards something they might be looking at. So we have multiple. So we might be looking at pose, and then from pose, we then can use audio cues to guide the user towards a person. Maybe they need to get closer for that person to be recognized. Maybe they need to go around towards that person's face to be recognized. So I would say that's the vast majority of what we do, is to build an experience and algorithms that enable that to happen. But I think once you've enabled that to happen, then you also have this problem is, does it do it accurately? And again, a lot of our research has been sitting around how do we make that happen? And that's for us happened in two ways. One is just a lot of thinking within what role does the technology play for the users who are using it. It can be easy for to think, well, it's going to replace a particular ability. It's like a medical device. Some of our, we've seen this to say, well, if it's for a blind person, it must be a medical device. It's replacing their vision. We've taken a view that actually many of the people that we work with have a lot of skills. So it's not replacing any of those skills. It's augmenting those skills. So how do we then make sure that we have a level of accuracy that can support that? And one way that we've done that is that we always provide information in multiple ways. So for example, when we're looking at people, we might provide the number of people plus an identification of those people. So if you see there are 4 people, but you only hear 3 names, you might automatically realize that that's a problem, that something here is amiss. So I might trust the system a little bit less, but not only trust the system, it's not about trust or not trust. That is a step to say, I need to do something different if I'm going to see if I'm going to get the information I need. And we can perhaps take the analogy for those people who are using vision. When you walk into a room, sometimes you can't see everybody is there, and you move closer to someone, you move around till you can see what you need to see. And so a lot of what we're doing in our experiences is helping people get that wider view so that they can be confident in the information, or they can make the choice. It doesn't matter if there are 4 people or 3 people, because my interaction is not going to depend on that. So I can push that away for the moment until I need that information next.
Very nice. I hear a lot of keywords here. Very interesting. Individualization, trust in the system, and be able to making choice, not just the system dictating you what to do. Dan and Patrick, any comments?
Yeah, one thing that I have noticed from running individual user studies is that there's a training phase, right? So we build a system and we come in and we teach someone, here's how you use our system. But everyone's doing that, right? You know, I'm seeing here from UT Austin, we have Microsoft, we have Google on the call. Like, we're all making these individual systems with different instructions. And it feels nice in our little silos to say, oh, we built a new tool, it'll help you. But there's such an overhead for every single tool for these people that have to learn how to use each one of them. And so I think one of the major challenges for the community of developers is, how do we come up with standards so that the population interfaces with one set of instructions, and we all as developers conform to them.
Nice, nice.
Yeah, just this is Patrick. Just kind of some additional thoughts on there. Like, I also think when it comes to user experience, a lot of the output, like the results of these products or these models, they're provided to the user in the form of audio, right? And I think that can be tricky sometimes, because of course these users use their ears to interpret the world around them a lot of times. And so we want to be really sensitive that we're not providing extraneous information. We want to keep our information through our audio channel really tight, so that the information we provide is useful and it doesn't necessarily get in the way of a user trying to interpret audio cues from the environment around them, like hearing cars or other people in the room and things like that. So just thinking about interface design, that's something else that we've tried to take a lot of care with.
Beautiful. The system must not be too invasive. Again, we need to be able to be in control, right? And to be able to function as we do. Fantastic. So the last topic of the day that I really want to touch is, well, we're talking about AI, and one could argue that your AI system is as good as the data set you've been training on. And a lot of people have been talking about bias in data sets. And here we are talking about a particular type of community. And you can be sure that most of the image data sets that systems are trained on might not be completely representative of the images that this community would take or would be interested in. And in fact, there are a few data sets that have been taken by blind people, and one of them is VizWiz. And Danna, you've been working on VizWiz quite a bit. Do you want to comment a little bit?
Yes. So traditionally in AI, the way that we can put out a problem is we imagine a problem, and then we go make up a data set that resembles that problem, such as scrape a bunch of images from the internet, ask crowd workers to come and describe those images, and then say we've produced this image captioning task. Or collect a bunch of images, ask crowd workers to make up questions about those images, and then go to crowd workers to say, now answer those questions. That's really valuable because it puts out the question for the community. But it's not valuable for real users yet, because we have yet to close the loop and actually connect to real users. And so The challenge for a researcher who's really trying to promote AI is how to plug into the community of developers who are developing systems that is collecting data. And so I actually did develop a partnership with a professor in human-computer interaction who had developed an application that was used by over 10,000 users, where people submitted images with questions about those images. And in partnership, that particular app had people opt in to say, yes, I'd like to share my data for future research and data set creation. And so then I jumped in and took that data and helped with my team package it for the community. So I think the greatest challenge is figuring out how to develop the right partnerships. And I'd like to say that also this person who I partnered with was in academia. And it's easier, I think, for academics to share the data than for companies. And so I know, for example, I've talked with people at Microsoft and Amazon, and I know that there's an interest in having data get shared, but there's so many layers of issues with privacy. And if any piece of private data got leaked, it would be, I think, it's just not a risk that I've heard from people in industry that they're willing to take right now.
That's a good point. And we have two people from the industry next to us. So Patrick and Cecily, do you have any comment on that?
Sure, this is Cecily here. Well, I think one of the initiatives at Microsoft is something called Microsoft AI for Accessibility. And one of the things that they've been doing is spending a lot of time trying to fund what I would call disability first data sets. So data sets that are collected by and for people with different disabilities, so that when these are then open sourced and made very visible to the research community, we start with applications that are already going to work for that disability, rather than try and say, we built this application, can we now make it work? So a good example of that in computer vision is if we start with ImageNet data, the data looks different. Maybe there's less blur, maybe the framing is different. And then we try to then retroactively get people to take better images, or we try to then artificially adapt that data to retrain. Or we can start with data that people who are blind or low vision have taken and go the other way. So for example, we're working on a data set called Orbit, which enables people to collect objects of things that are of interest to them, which is then going to move on to the community to try and help the community really push for this idea of personalization, that we can start to build algorithms that in the first round will maybe give us what we call personal object recognizers, something that will recognize something that's very personal to you, whether it's your computer, your wheelie bin, or maybe a landmark that's really critical to you. But then go on to push that on to say that once we can personalize a small task, can we start personalizing the information we give you? Can we start personalizing the experience that we give you? So if people are interested in contributing and being part of a disability first data set, you can try that at orbit.ac.uk. Sorry, orbit.city.ac.uk.
It's beautiful. Patrick, I'll give you the last word because we are about to close.
Yeah, so I think this has been great to hear. Yeah, I do think like there's a gap here where it comes to kind of this public corpus of data, and maybe a concerted effort among some of these organizations and academia and company to kind of provide this data and sanitize it to remove public or private information that might be there. I know that can be an issue too. And these data sets are really a reflection of images that individuals have taken and labeled, and they might reflect the bias of these individuals also. So it's really important to kind of assess any bias that might exist also in these data sets and these models. And that's something we do here at Google that we're learning how to do, and we have a lot of efforts going on, is how to evaluate what bias may exist and eliminate that. But I think we're also kind of in the early stages of this, just from a research and technology standpoint. And there's a lot of work ahead to create representative data sets that will be useful for these users, and to do things like eliminating that bias. But yeah, it's really important, and I'm hopeful for what the future holds.
Fantastic. Well, thank you so much. Thank you to all of the panel, Danna, Patrick, Cecily. I think this has been an exciting panel. I learned a lot. I hope everybody who's been listening has as well. So thank you guys again, and we can pass it on now back to Will Butler. Thank you, everyone.